Hey guys, it's Professor Watson here. Welcome to week 6 of Managerial Finance 301. This week we are going over chapter 5, which is our time value of money chapter. So a couple things to note kind of here going on out with the class. You're going to need your BA2 plus financial calculator. So I have a computer app pulled up on the right hand side of my screen that I'm sharing with you. This is what your BA2 looks like. You can use a phone app or a computer app if you want to. Just keep in mind that during your test you will have to have an actual calculator. You can't use your phone. So today's lecture I'm going to go ahead and teach you how to use the calculator, and we're going to introduce time value of money concepts to you. Another really important thing to keep in mind here is the first module of this course was, a lot of vocab and just a lot of general reading. The rest of this course gets very hands-on. There's a lot of use of your calculator, a lot of equations, a lot of, very intense finance equations. And so a lot of it builds off of time value of money. And so, getting these time value of money concepts down is really key to your success in this class. So as promised, I want to give you all the tools that I can to help you succeed. So this lecture is part of those tools for you. So it's a good tool to have. I'm going to walk you through some of the questions here in the lecture. I'm also going to, later this week, put up some practice exercises for you in a lecture like this, where I walk you through how to do the problems. I think that's pretty helpful for people. So just kind of keep some of that stuff in mind. You're always welcome to email me or text me if you have any questions. So let's go ahead and dive into time value of money. Your book really explains time value of money, and I think sometimes it's easier said a different way, and so I like to do this lecture for you to really break it down, because time value of money really is a very simple thing. So we're going to talk about a few different things here today. We're going to talk about future value, present value, and if you don't know what any of these mean yet, you will. I'm just introducing them to you. We're going to talk about finding your I, which is your interest rate, or N, which is your period. We're going to talk about different kinds of annuities, rates of return, and amortization schedules. So lots of fun stuff in finance today. So what is time value of money? Your book defines it as $1 on hand today is worth more than $1 promised in the future. And simply all that time value of money is that today, if I take my money and I invest it, it's going to be worth more in the future than if I don't invest it. So $1 on hand today can be invested to earn interest and gain value. Compounding the present money to the future date by finding the value of present money. So compounding and discounting are two different terms that you're going to hear throughout this entire class for the remainder of the semester. Compounding simply means that I'm going forward in time. So I'm taking the present value of something and I'm trying to find the future value of it. Conversely, discounting is taking the future value of something and going backwards in time and trying to find the current value of that money. So compounding is going forward, discounting is going backwards, essentially. So as we go through this lecture, eventually by the end of this course, you'll be able to calculate and value all sorts of assets. But today, while we're going through time value of money, I want you to think about a savings account. It's a really simple example, and it's a really easy way to understand and learn what's going on with this concept. So as you work through some of these questions, a timeline is always very, very helpful to draw for you to kind of understand the problems and give you a visualization of what's going on. I remember in my undergrad, this is how I learned time value of money. So let's take a look at that timeline there. The timeline 0, anything that's you see CF 0 or cash flow sub 0 means today. So anything that has a time period of 0 means today. And then you can see the following periods after that, 1, 2, 3, and so on. These periods could be months, they could be years, they could be days, they could be quarters. It is all defined by the problem that you're trying to solve. So just because it says cash flow 1 doesn't mean that that's a year. It's just a tick mark of a period in time. So we have a couple different timelines here. The first is a $100 lump sum due in 2 years. So when we have a lump sum, think one pot of money. And on this timeline, it's pretty evident. It's $100, and you'll see it there in year 2 as it's due in 2 years. So we deal a lot with lump sums. We value lump sums in this class. We also value annuities, and annuities get pretty tricky. and I'll try to break them down for you. But an annuity essentially is a payment towards something. So if you look at that second timeline down there, think about a savings account. You are putting $100 in your savings account for 3 years every year. And so you have 3 individual payments of $100 to that savings account where the lump sum was just one entire lump sum of money. So as you go through these problems, drawing that timeline can be very, very helpful to help you better understand these concepts. We're also going to talk about uneven cash flow streams, and this one's pretty straightforward. I have today, my cash flow in year 0 is -50, and then I have following uneven cash flows from that point out, $175, $50. So we'll also talk about some of those uneven cash flow streams and how to value those as well. So let's go ahead and get started. I'm going to stop my lecture here for just a second, and I'm going to go ahead and explain your BA2 financial calculator. So let's go ahead and look at the right side of our screen here. So your calculator should look much like this, and what differs this calculator from all the other calculators out there is this function in the third row, and this is your finance function right here. So you'll notice from left to right we have NIYPV payment and future value. So let's go ahead and break down each of those inputs real quick. So your book probably breaks these down, but I'll mention them to you again. So N is your period. N is how long you're investing your money for. It could be years, it could be quarters, it could be months. N is just a period in time. IY is your interest rate. So whatever interest rate in which you're investing your money at. PV stands for present value. So it's the current value today, the value of your money. PMT, or payment, or otherwise known as an annuity, is just like that timeline we just looked at, where there's reoccurring cash flow in the series of cash flow. And then FV stands for your future value. So what is the future value of my cash flow stream, or what is the future value of my lump sum of money? So what I'm going to do today for you is I'm going to help you walk through and solve each of these inputs so you can better understand how to solve some of your homework. A majority of your homework is just solving for one of these inputs, but of course it gets a little bit more complicated than that. So this first part of this lecture is very straightforward, very simple calculations. I will also get that lecture up for you, kind of helping you work through some of your homework problems because they're not as easy as this. So this question asks, what is the future value of an initial $100 after 3 years if my rate of return is 4%? Well, what does that mean? What we're really trying to find out in this question is, what is the future value of my $100 that I have today? So if I take $100 and I invest it in a savings account for 3 years at a rate of 4%, how much money am I going to have in 3 years? So if it helps you, if you're a visual learner, you can go ahead and draw out that timeline just like they have down here. So today, year 0, or today's point in time, I have $100, and I'm going to travel in time 3 years to find out what the future value of that money is. So your book likes to break out the equations of this, the algebraic equations, and for some of the inputs you can solve this way. I would recommend, the math gets way too complex as we get further into the course. I recommend you get very familiar with your calculator. That's what you're given on the test to use. So this is one method to solve the problems using those formulas, but we're going to go ahead and use our calculators. So we're going to move to slide 8 here. So the calculator on the left, or on the right here, excuse me, let's go ahead and just plug this problem in. So let's talk about the calculator real quick. So this calculator, when you first start, to make sure it's in the correct mode, and I'll explain later the different modes that this calculator can be in, but to make sure it's in the correct mode, you want to make sure that we just have 0 here on the screen, and in the right hand corner there's no other indication. It doesn't say end, it doesn't say beginning, it doesn't say anything else. If your screen looks like this, you know that you're okay to go ahead and solve this problem. So this calculator is very simple. You go in sequence through your inputs from left to right, and you simply type in the number and click the input, and so on until you solve for your input. So let's go ahead and solve for this problem. So I have this $100 that I'm going to put into my savings account for 3 years at a rate of 4%. So my N, or my period in this question, is 3. So I'm going to go ahead and type in 3 into my calculator, and then I'm going to select N. I know that this number has been input into my calculator when this equal sign shows up next to it, okay? So you're just going to move on to the next input. You don't have to change anything. So we know that we are investing this money at a rate of 4%, so we're just going to type in 4 and hit IY. And so we know from this equal sign that that's been input into the calculator. So we know that today we have $100, and that's the present value. $100 is how much our $100 is worth today. Pretty straightforward. So we're going to plug this in as 100, and I'm going to put a negative on that 100, and I'm going to come back and explain that to you in just a minute. But let's just worry about getting familiar with our calculator. So we're going to plug in this $100 into our present value. Now, here's the thing with this function. You can only solve for one input at a time, and if you don't have an input that's not being taken into consideration, you simply enter 0. So in this question, we didn't mention anything about a payment or an annuity, so we're just going to go ahead and forego that input, and we're just going to plug in 0 for our payment. And then we're going to go ahead and compute for our future value. So to compute for any of these inputs, you come up and press compute and press for the input in which you are solving for. Remember, you have to go in sequence on your calculator. It has to be from left to right. Whatever input you're solving for, you simply skip over. And if you don't have an input that you're not solving for, you just simply plug in 0. So let's go ahead and talk about that negative $100 that we just put in. So what we've solved for is the future value. What this says is that my $100 in 3 years at a rate of 4% is going to be worth $112.49, okay? Well, what's that negative? Unfortunately, it gets a little bit more complex. We have to have a negative in this function. So the way that I want you to think about a negative is, where is my cash flow going? If I am going to put money into a savings account physically, the $100 is going to leave my pocket, and in 3 years, I'm going to get a cash flow injection of $112, which will be positive to my cash flow stream. So think about in terms of where your money is flowing, okay? So even though you put that $100 in your own savings account, technically it did leave your pocket. You had to hold it for 3 years, and then you got it back. Therefore, your future value is positive. So you just solved for future value, which is one of the 5 inputs on your calculator. So now let's go ahead and solve for the present value. The nice thing about this lecture is that it uses all the same variables to keep things simple. So we're going to take those same variables, and instead of taking that $100 today and finding out what its future value is, we're going to assume that 3 years from today we have $100, and now we need to find out what its present value is. So come back to your calculator here on the right, and we're going to go ahead and clear this out. And your book is very, very helpful. Again, you can do the formula method here if that helps you understand this, but I'm going to switch to slide 11 here. Again, come back to this as you're going maybe through this lecture and look at the inputs and outputs. Your lecture does a really great job of helping you understand where all those inputs are. And this is something I recommend as you work through these problems. Write down N through FV, all 5 inputs, and just start kind of, plug and play and see where you get in these problems. So instead of solving for the future value, we're going to solve for the present value. So it's the same time horizon. We still have a period or 3 years. So we're going to plug that in for our N, and I've cleared my calculator out. Our rate is still the same, so we're still investing this $100 at a rate of 4%. This time we're solving for PV, so since this is what we're solving for, we're just going to go ahead and skip over the input. We're going to go ahead, we didn't mention anything about a payment as before, so we're going to plug in 0 for our payment. Our future value is $100, okay? And it's going to be a positive $100, and I'll come back to that cash flow conversation in a second. So I've got 4 of my inputs in, and then I'm going to click Compute PV. And what it tells me is that today, my $100 3 years in the future, today is actually worth $88.90. Another way you could state this question is, if I invested today $88.90 in my checking account for 3 years at a rate of return, it would be worth $100 in the future. So the present value here again is negative because the $88, if you look at it from that point of view, is leaving my pocket, and in 3 years I'm getting back a positive or a $100 from that savings account. So there you've solved for 2 of the 5 inputs. So let's go ahead and move on. So let's go ahead and solve for I. I is your interest rate. So, as complex as all these inputs might seem, or as simple as they may seem, you can solve for all of them on this calculator, and that's what's so nice about the BA2 Plus. So let's go ahead and assume that we have to find out what the annual interest rate is that would cause $100 to grow to $119.10 in 3 years, okay? So let's go ahead and plug this in our calculator. We know that we have a time horizon or a period of investment of 3 years, so we're going to plug that in for our N. We're solving for that interest rate right here, so we're just going to skip over that input. We're going to take $100 and we're going to grow it. So think about maybe that savings account again. You're going to put that $100 into the savings account and you're going to grow it. So we're going to plug in a negative 100. And keep in mind when you guys plug in these negatives, you don't plug the negative in first. You plug in the number and then apply the negative to it and then plug that in for your input. We don't have a payment in this question, so we're just going to plug in 0 for the time being. And then we know that our future value, or the money that we're going to get back, is $119.10 that we'll plug in for that future value. So then you can click Compute IY, and that tells us that we would have to invest at a rate of 6% to cause $100 to grow in 3 years to $119.10. So you solved for 3 of your 5 variables, so let's go ahead and talk about N. So N is our period. So this question's a little, doesn't give you a lot of information, so we're going to assume a couple things here. What this question says is, if sales grow at 10% per year, how long before sales double? But what this question doesn't tell you is what sales are today. So we're, just for the simplicity of this lecture, we're going to assume $1 for the sales, okay? So we are going to go ahead and solve for this. So we're going to skip over N because that is the input that we're solving for. So we know that we're going to have sales growth of 10%. Our present value is that $1 that we're talking about doubling. It's going to be a negative $1. We don't have a payment in this question, so we're just going to go ahead and put 0 in. And if we're doubling $1, that means that it's going to be $2, right? So we're going to have a positive $2. And then we're going to go ahead and compute for N. So essentially what this is saying is that at a rate of 10%, it's going to take me almost 7.5 years to take my $1 and grow it to $2, okay? So a pretty long time horizon, which seems at a pretty high rate, but if we were talking in millions, this could be pretty substantial for a company. So you've solved for 4 of the 5 inputs. The first 4 are very, very simple. Annuities, kind of like I had mentioned before, are quite a bit more difficult and they get pretty complex. And so I want to spend some time here explaining annuities to you and working through a few of the problems. So there's 2 different types of annuities, and remember the annuity is referring to this payment button on your calculator, and it means a recurring payment, a recurring annuity essentially. So the first timeline up there says ordinary annuity, and the only difference between that and annuity due is an ordinary annuity happens at the end of the period. So you'll see right here the payment is being applied at the end of the period. So from today, 0 to period 1, the payment is at the end, okay? And you'll see that through this timeline. The difference between an ordinary and an annuity due is that an annuity due applies the payment at the beginning of the period. So a lot of people ask me, well, what is the advantage to that? Why would I ever have an annuity due? Why would I apply my payment at the beginning? Well, an annuity due will compound for 4 periods, while an ordinary annuity will only compound for 3 periods. And so an annuity due will always earn more money than an ordinary annuity. Okay, so that's the difference. So when you think of an ordinary annuity, I want you to think payment at the end. And when you think of an annuity due, think about the payment at the beginning. Because not only is this important for you to know the annuity, this is also very important for you to understand about the modes of your calculator. And we'll get into that. So think end, beginning. We're going to come back to that. So slide 15 here. So let's calculate an annuity. So it says find the future value for a 3-year ordinary annuity of $100 at 4%. So I'm going to stop right there and I'm going to show you another function here on your calculator. So when I started, remember I told you up here in the right hand corner on your calculator, I want you to make sure that there's no kind of designation or function up there. It doesn't say end, beginning, it doesn't have anything up there. Your calculator always calculates in an ordinary annuity. So it always assumes that if you have an annuity or not, it's happening at the end of the period, okay? Well, sometimes we're going to have to learn how to calculate within an annuity due, and that's the beginning mode. So to change my calculator from end mode, which is ordinary annuity, to beginning mode, which is annuity due, I'm going to go ahead and press second, beginning, which is above the payment button, and this tells me what mode my calculator is in, and it says end. It means I'm calculating an ordinary annuity. We knew that, but if I want to switch it into beginning mode, I would then press second, set, above the enter button, and this would change me or switch my calculator into beginning mode. So if you clear out, now we have this designation BGN up here, which means that we're ready to calculate an annuity due. So in this question, we just want to calculate an ordinary annuity, so we can switch back our calculator by pressing second, beginning. It tells us what mode we're in, and then second, enter, puts us into the other mode in the calculator, which is end, okay? We know that we're in end because nothing's up here in the right-hand corner. So now that you've got that lesson, let's go ahead and calculate an ordinary annuity. So solve the future value for a 3-year ordinary annuity of $100 at 4%. So it's pretty straightforward. I have this annuity. My period of investment is 3, so my N is 3. It's at a rate of 4%. I don't have a present value. So a lot of people ask me, well, I have a payment, I should have $100. Well, with an ordinary annuity today, you don't have any because the annuity is coming at the end of the period. So today, your present value is 0. So you plug that into your calculator. And then your payment is 100, right? And that's a negative payment to you because that's money that's leaving your pocket. Okay, so we'll plug in a negative 100 for our annuity in our calculator, and then we will compute for our future value. So what this is saying is that I don't have any money today, but I'm going to, with an ordinary annuity, invest $100 at the end of the period for 3 years at a rate of 4%, and my future value of that annuity is worth $312.16. So, just like a future value of that annuity, we can also solve for the present value of that annuity. And this is where the negative gets a little tricky. The rule that I told you before applies to all the other functions except annuities. That, where's your cash flow going? Is it negative to me? Is the cash flow positive to me? With an ordinary annuity, I don't have a very good rule for you, but to tell you that when you're calculating for the present value, your negative is on the present value. So let's go ahead and look. So same question. We're going to go ahead and plug in our variables just like we did. So it's still a time horizon of 3, a period of 3. It's a rate of 4%. But this time, we're trying to solve for the present value of this annuity. So we're going to go ahead and skip over it. We're going to input $100 for our payment. And because we're solving for present value and we were not given a future value in this question, we're going to go ahead and plug in $0 for our future value. Your future value is not always 0 when you're calculating the present value of an ordinary annuity. Just in this question, we weren't given that variable, so we're just going to go ahead and plug in 0. But that does change, and you'll learn later on that that can absolutely be a factor. So we're going to go ahead and click Compute, Present Value. And what this is saying is that, yeah, I can invest $100 for 3 years, but today that money, that $300 essentially, is actually worth $277.51. And that would be my investment amount. Okay, so then let's switch gears. So we solved for our ordinary annuities. Now we need to solve for the annuity due. The nice thing about solving for annuities is that you don't have to change your method. You don't have to change anything that you're doing in your calculator except for your mode, okay? So we're going to go ahead and clear out, and we're going to use that same function we did before. Because this is an annuity due, we need to change our calculator into beginning mode. So we're going to come over here to our calculator, and we're going to press second payment, second enter, and clear, and that will change us into beginning mode, and we're ready to solve for this annuity due. So it's the same annuity that we were just talking about, 3 years at 4%. It's a $100 annuity. So we're going to plug it in, 3 for our N. We're going to plug in 4 for our IY, 0 for our present value because we don't actually have any tangible value today, 100 for our annuity or our payment, and then we're going to compute for our future value. So you'll notice here that the annuity due, the future value of this annuity is $324.65. If we switch back to slide 15, you'll notice that, and remember that ordinary annuity happens at the end, that you'll notice that its future value is $312.16 because it compounds for 1 period less than an annuity due. So my ordinary annuity's future value was $312 and my annuity due's future value was $324 because my annuity due compounded for 1 more period because the payment happens at the beginning of the period. So another question I get a lot on these questions, type of questions is, well, if I'm applying my payment at the beginning of the period, shouldn't my present value be 100? And my answer is no. Think about today, if you open up a savings account, your present value is 0. If you're dealing with an annuity due, think that on day 1 of your savings account, so tomorrow, that is when you apply the payment. So your present value today is still 0. And then vice versa, just like we did previously with the ordinary annuity, we can solve the present value of the annuity due. So same thing, our N is 3. We're investing for 3 years at a rate of 4%. So that's our IY. We're solving for the present value, so we're going to go ahead and skip over that. Our payment is 100. So remember, with a present value of an annuity, your payment is positive and your present value is negative. We don't have a future value, so we'll plug that in as 0, and then we'll compute for our present value. And what we find there is that, again, that annuity due, present value and future value, is worth more than an ordinary annuity because of that extra compounding period. Okay. So let's go ahead and switch our calculators back into end mode. So second beginning, second set to change it. So here they want to know what is the present value of a 5-year $100 ordinary annuity. And the point of this question is to get you to switch your calculator back. This is a big thing that you need to be very cognizant about when you're using your calculator, is that while your inputs are all the same, the process is all the same, if your calculator is in the wrong mode, even if all your inputs are correct, you will still get the wrong answer if you are not in the right mode. So the whole point of this is that we changed from an annuity due in the previous question, and now we're dealing in an ordinary annuity, okay? So 90% of the time you're going to deal in end mode in your calculator because we're generally dealing with ordinary annuities. Unless you see annuity due, that is the only time that you need to change your calculator back into beginning mode, okay? So it's probably a good habit to always make sure that this upper right-hand corner is empty, doesn't say anything unless we're dealing with annuity due. Okay, so let's talk about annuities really quick and the importance of them. So this diagram here displays the difference between a 10-year, a 25-year annuity, and a perpetuity. So you'll notice that, and you can plug these into your calculator on your own, but you'll notice that if I take a 10-year annuity, a $100 10-year annuity at a rate of 4%, you'll notice that my present value is worth $811.09. My 25-year annuity The only thing that's changing here is my length of investment. The present value of my 25-year annuity is $1,500 roughly. So the point is, the longer that my annuity is, the more worth I have in that annuity, the more my present value is, right? Then we have this new term, maybe you haven't heard, it's called a perpetuity. So a perpetuity simply means that it goes on forever. And a perpetuity means that, can an annuity go on forever technically? No, but it can be expected for a long period of time. It's always expected. So this is on your test, and you might hear this. A perpetuity is not any kind of fancy financial function that we have to use in our calculator. A perpetuity is simply calculated by taking the payment divided by the interest rate, so taking that $100 annuity divided by that 4% we've been working with. And you'll notice that a perpetuity, its present value, excuse me, is worth $2,500, which is far more than our 10-year or 25-year annuity, because that perpetuity essentially goes on forever. So it's worth the most to our investors. So compound interest. We've been talking about compound interest and dealing with compound interest this whole time. And when you think about compound interest, think the interest that I earn today is going to compound into the next period, and whatever I earn on that, I'll earn interest on that, and I'll earn interest on that, and that's what compounding means. I'm earning interest upon my interest that I've already earned. So let's kind of display the power of compound interest. Why is it so important? Why do we use it in finance? So this is a great example of one of your homework questions, maybe a few of your homework questions. This one's much more detailed than the previous questions that we've been working on. So let's go ahead and break this question down. So it says a 20-year-old student wants to save $5 a day for her retirement. So every single day she places $5 in a drawer. At the end of the year, she invests the accumulated savings of $1,825 in a brokerage account with an expected annual return of 8%. So you've got a lot of information, but the question that we're trying to answer here is, how much money will she have when she's 65 years old? So you might look at this question and say, okay, what kind of inputs do I have here? One of the first mistakes that's easy to make on this question is, well, my N or my period is either 20 or it's 65. Well, that's not right. Remember, the N is the period in which she has to invest. If she's 20 today and she lives to 65, for her investment, she has 45 years essentially to invest her money. So let's switch to slide 22 here, and let's take a look at this. Let's break the question down. So we know if she's 20 today and she wants to retire at 65, she has 45-year time horizon to invest her money. So we're going to go ahead and plug in 45 as our N, and make sure again that we're not dealing with an annuity due here. We didn't say anything about that our calculator is in end mode. And we know that because it says at the end of the year, she invests the accumulated savings, not at the beginning. So we want our calculator in end mode. So she is investing this in a brokerage account at 8%. So we're going to plug in 8% into our interest. Now, the question says she's going to save $5 a day. So you might think, well, she might have $5 today. Again, kind of like with that annuity due conversation, she doesn't have any money today. She's starting to invest at the end of the year. She's going to take the accumulation of these $5 bills, that $1,800 invested at the end of the year, so she doesn't have any money today. So we're going to go ahead and plug in 0 for our PV. We're going to go ahead and plug in that $1,825 for our payment, and that's going to be negative because, yes, is she putting that in her own retirement account? True, but she is going to take that money out of her cash flow, and in 45 years, she's going to get back the money. So her payment or her annuity in this question is negative. So once we get that put in, we can go ahead and compute for our future value. And what this is telling us is that this 20-year-old girl today, she's going to invest for 45 years, and she's going to put forth $1,825 a year. And at the end of those 45 years at 8%, she is going to have saved $705,000 roughly in her retirement account. Now let's change the scenario a little bit. Let's say that she doesn't start saving until She's 40. How much money is she going to have at 65? So the N is not 40 in this question. The N is not 65 in this question. If she's going to live to 65 and she's now 40, she has now 25 years to invest her money. So we're going to go ahead and clear this out of our calculator. So we're going to change, the only thing that changes in this question is our N. We're going to change 25, plug that in for N. We're going to plug in 8 for our IY, 0 for our present value. She doesn't have any money today. We're going to plug in $1,825 for the payment, and then we're going to compute for our future value. And you'll notice that when she cuts off roughly 20 years from her investment time, she goes from $705,000 roughly to $133K. So she loses a significant amount of retirement savings. So if you get anything out of this question, it's that you should start saving early with your retirement account. So make sure that you're getting signed up for that 401k through your employer, or that you have some kind of retirement account, and start young, start in your 20s. Because what happened here is she lost $571,000 in her retirement account when she waited 20 years to do so. So let's go ahead and answer another question. So let's assume she's 40, and let's assume that she wants to catch up to the 20-year-old or her 20-year-old self, right? So she's 40 now. Her time horizon is still 25 years, but she, in 25 years, wants to get to a retirement amount of $705,000. The question we're trying to answer here is, what does her payment look like? What does the annuity look like that she's going to have to put into this brokerage account every year? So we'll clear out our calculator. We're going to plug in 25 for the N. We'll plug in 8% for the IY, 0 for the PV. She doesn't have any money today. We're going to skip over her payment because that's what we're solving for. And we're going to plug in the future value, which was the 20-year-old's retirement account balance, for our future value. And then we're going to compute for the payment. So you'll notice she went from an $1,800 payment roughly, and now she has to contribute $9,600 to her retirement account to catch up to the 20-year-old. So again, make sure that you start saving early. Okay. So then let's talk about one last thing here with our calculator. So we've solved for all different inputs. We've solved for period, interest rate, present value, annuity, and future value. At the beginning of the lecture, we had a little timeline that explained uneven cash flow streams for you. And we can also solve those cash flow streams to find out what the present value of those cash flow streams are. So luckily, with this nice calculator that you have, there's a function that does that for you. But let's go ahead and just simply break this question down. If we look at this, the question asks, what is the present value of this uneven cash flow stream? What is it worth, okay? So if we look today at our cash flow stream, today we don't have anything, but in year 1, we are expected to have $100, in year 2, $300, in year 3, $300 as well, and in year 4, -50, okay? And we want to know, these are the future values, that's all good and well, but what is it actually worth today? So one method is called discounting, and I mentioned this earlier. So we're taking a future value and we're bringing it back into the present time. Okay, so we're going backwards in time. That's called discounting. So what this shows is individually discounting each of these cash flow streams. So I'll show you the first one just to give you an idea, and then we'll actually use our cash flow register to solve this problem. So where do they get this $96.15 as our present value today? Well, they take this $100 and they discount it. So we plug in our N as 1 in our calculator. Our interest rate in this question is 4%. They've given that to you there. And our present value, that's what we're solving for, so we're going to skip over it. Now, people get pretty confused here when we discount individually. Yes, this is an annuity. In the grand scheme of this entire uneven cash flow stream, this $100 is an annuity. It's a payment. But when you individually value each of these cash flow streams, that payment actually is the future value. So in this question, we're going to actually put in 0 for our payment, and the $100 is going to go into the future value. So go back to your fundamentals and think, I'm just solving for a present value. I'm just solving to find out what the present value of this annuity is. It's just like the future value, okay? So it can be a little bit confusing there between payment and future value of that annuity stream. Just remember that when you individually discount, that annuity actually is the future value. So then we can go to compute present value, and we find out that this $100 in year 1 today is actually worth $96.15. So you could go through each of these cash flow streams and do just what I did. You would change your N for the corresponding period and then change your future value to the corresponding number indicated below that period. So after we've found out the present value of all these cash flow streams, we add them up to find the present value of the cash flow stream. And this is what we call net present value. And the only difference between net present value and present value is net present value is the sum of many present values, just like we did here. So of this $100 and these $300 and this negative $50, today it's all actually worth $597.48. So that's a lot of work, and you can approach the problem that way. My suggestion to you on a test is that takes too much time, and so you should learn to use your cash flow register. So if we go to slide 26 here, we have this nice function up here. Let's clear our calculator out. We have this nice function on our calculator called CF, and this is our cash flow register, okay? So the first thing you want to do in here, and if you've never used your calculator, this will already be clear, but to clear your cash flow register out, you will want to click Second, Clear TMV, Clear Work. Okay, so that was Second, Clear TMV, or Time Value of Money, Clear Work, and that'll clear your register for you. So let's go ahead and just plug this problem in. So they've converted this problem from the timeline in slide 25, and they've now converted it into this cash flow register format for you. So when we open up, and I'll start over here again, I'll clear this out. I'm going to click on cash flow on my calculator. So when we start, you'll notice we have this input called CF sub 0. So remember, that's today's money. You might actually have money today in your cash flow stream, but for this question, we don't. We have 0. So this is already an automatic entry. It's already input in the calculator. It's a very simple function. You just arrow down through the functions, or through the inputs. So if we arrow down, we'll come to cash flow, and your calculator shows it as CO, but it really is the cash flow, like over here in the lecture to your left. So this is cash flow in year 1. So we know that our cash flow in year 1 is 100, so we're going to go ahead and plug in 100. And the only thing that differs here with this input is you have to hit enter after you input the number. So we're going to put in 100 for our cash flow in year 1, and we're going to arrow down. And what you're going to notice is this FO1 come up. And what that means is frequency. It's asking how many times does the cash flow in year 1, how many times does that $100 repeat itself, okay? So it could repeat itself 5 times and our frequency would be 5, but if we look at year 2, we notice that our cash flow is 300, therefore our $100 only has a frequency or only repeats itself once. So we'll leave that frequency of 1 in there and we'll arrow down. So cash flow number 2 comes up, and that's $300. So we'll go ahead and plug in 300 and hit enter. And then we're going to arrow down. Now if you get really comfortable with your calculator, and for simplicity we're just going to enter 1 here, but if you become very comfortable with this cash flow register, you could plug in 2 here in your frequency for cash flow in year 2, because technically that cash flow of 300 does repeat itself in year 2 and in year 3. But for right now, let's just keep it simple. So we're going to go ahead and arrow down into cash flow year 3, and we're going to type in 300 and hit enter. Arrow down the frequency of 1, and then we're going to arrow down again for our cash flow in year 4, and that is negative 50. So you're going to type in 50, apply the negative, and hit enter. Okay, and then you can arrow down for that cash flow frequency in year 4. So you'll notice that your cash flow register goes up into higher numbers. As long as there's nothing entered in there, as long as it says 0 and you've cleared out your cash flow register, you should be fine. And you can go back and scroll through this cash flow register to make sure that all of your inputs are correct. So once you've done that, you're going to click this button called NPV, which means net present value. So you're going to press net present value, and we're going to enter our interest rate here. So we were told that we were going to invest this cash flow stream at a rate of 4%. So we're going to plug in 4 and hit enter. And then we're going to arrow down, and we're going to come to this this input called NPV, which is that net present value. And so after we've entered all of our cash flows and all of our frequencies and our interest rate, we just simply click compute. And you'll notice that that is the same number, this $597.48 is the same number that we came to when we individually discounted each of these cash flow streams. My recommendation to you is to use your cash flow register.